All right, welcome everybody. Let's do this. So first off, my apologies for this kind of like annoying symbol over here and whatever is like down here. I'm using this new program and it's not letting me get rid of it, so kind of just ignore it. But yeah, so here, the idea for today's lesson is what does it look like when we're sketching tangent lines and how do we find its slope? So here, what I'd like you to do is just first take a second and copy this down into your notes, this visual of this curve with these points on it and the definition for a tangent line. Yeah. So let's say you have it in your notes. A tangent line touches a curve at a point and it's going to match its slope. Here, before we talked about secant lines. Like secant lines, what did they do? They connected, let me get the marker. They connected 2 points on a curve like this, right? Like if I drew a line from here, from this point to this point, that was a secant line. Here, the idea of a tangent line, think of a line giving this point a kiss. Just like one little mwah, kiss over here. And what on earth am I talking about? A tangent line for this point would look something like this, where I'm drawing the line and it's only going to touch this point over here, just like that. And if it goes through this curve, it's okay, but as long as it hits this one point, that's okay. And notice that whatever the slope of this line is, that is the slope at this point on this curve, right? What if I were to draw a line that only hits this point on the curve that gives it a kiss? It would look something like here. It gives it a mwah, just hits it right over there. And this is a tangent line on this curve at this point. What I'd like you to do is just try on your own, draw tangent lines for this point, this point, this point, this point, and this point. Okay? Here, let's try draw one. It should look something like this. It just hits it just at that point. And mine was pretty bad. Let's try another one like this. Oh god, I completely messed that one up. Maybe something like this. Notice that this tangent line only hits this point on the curve. What about here? We could do something like this. Something like this. And something like this. Okay, so notice that it's just hitting these points on the curve, and each of these lines that I'm drawing, the slopes of these lines are what the slopes of these curves are at that point. So that'll take time to digest. What I'd like you to do is try and sketch this figure over here and just have some fun and sketch some tangent lines, okay, with what I have here. Yeah. And okay, so what would this tangent line over here look like? Okay, we have something like this, something like this, and notice, hey, what is the slope of a line that looks something like this? Notice, what can you tell about this slope over here? This has a positive slope. What's the slope of a straight horizontal line like this? This slope is 0. This slope, this is some positive slope. Notice that this is some negative slope. Right? This slope over here is negative because the graph is going down at this point. And here this is like some positive slope. Okay. Okie dokie. So hopefully we have an okay understanding of what tangent lines look like on a graph. Now here, the next thing within calculus that we want to kind of find out is, let's say if we have this function. And for this function, negative 5x squared plus 2x minus 12. It says find, well, take a second and copy this down, yeah? Find the slope of the tangent line at x equals negative 8. So what's happening here? We have this graph, f of x equals negative 5x squared plus 2x minus 12. This is the graph. It's saying find the slope of the tangent line at x equals negative 8. So if we go to x equals negative 8, we have this point on the curve. Notice we want to draw a tangent line that looks like this. Okay? Now, congratulations, you drew your tangent line, but the question that we want to find out is, hey, what is the exact slope of this line, of this tangent line on this point on the curve? Or, you know, that's what we want to find, okay? So how do we actually do that? How do we actually find the slope of this line given this information? Okay, so here, what we did before was, if I said, hey, if we have f of x is equal to negative 5x squared plus 2x minus 12, what does f of negative 8 find? What happens if I plug in negative 8 into this function? Please pause the video and try and answer this question. If we plug in negative 8 in here, into f, what does it find? And we did this before, but this should find the y value. So if I know that for this graph, if I know for this point, the point over here is negative 8. Hey, what is the y value, question mark? What do? You just take negative 8 and you plug it into this function and it gives you what the y value is, okay? What we want to do, wouldn't it be great if we had a process that would find the slope of any tangent line on a curve? And this is finding the derivative of a function, okay? When you find the derivative of this function, if I plug in f prime of negative 8 into my function, into the derivative, what this will do is it will find, if I plug in negative 8 into here, it gives me the y value. If I plug in negative 8 into the derivative, it tells me the slope of this tangent line at that point at negative 8. That's what we want to do. That's what the derivative calculates. And the process of going through the derivative, we did it in class a while back, but here we'll kind of go through the process again, right? This should look very familiar. So then what was that process we did before, and how can we actually find what the derivative will be? So we'll go step by step. Okay, so hopefully you have this in your notes. Here, step number 1. Find, we have this function, right? It is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, how did we go through that process? The first move was, what is f of x plus h? So notice that if f of x is equal to this, what would f of, oh, my bad, x plus h look like? Actually, let me use a different color. Let's use like orange or something. F of x plus h. So my bad. X plus h. Okay. What will it look like? Let me make sure I don't. Let me do this real quick. Okay. So here, this would equal negative 5. Now, anywhere I see x, what am I going to do? I'm going to plug in x plus h. So this will be parentheses, I'll put x plus h squared plus 2 times x plus h minus 12. So then now here we have is equal to, now here what we need to do is a little side note. What is the algebra that figures this out, right? I'll just do a little thing over here, and you can show this on the side. But if I have 5 times x plus h squared, you're not multiplying the 5 first on the inside. You have to do this x plus h squared first. And what does that look like? It looks like x plus h times x plus h. And how would you actually do this? Hopefully we're all solid with FOIL, right? X times x, x squared. X times h, xh. H times x is hx, but we're going to show it as xh so we can combine these two terms. And then h times h is just h squared. So then this is x squared plus 2xh, because we're combining these two, plus that h squared. Now we have to multiply the 5. So then it's 5 times x squared plus 10xh plus 5h squared. Okay. Okay, so then this becomes, oh, whoops, sorry. This is negative 5. Oh, my bad. So this is negative 5, negative, and negative. This should be a negative here, my bad. So then we have negative 5x squared minus 10xh minus 5h squared plus, now this part is easy. 2 times x is 2x plus 2h minus 12. Okay, great. Now we did the first step. We calculated x plus h, right? Because when we look at the derivative, there's this part over here that we had to do first. Now what we're going to do is, we just found f of x plus h. It's this whole shabam. We're going to plug in this whole shabam into this f of x plus h. Okay, so here, that was step 1. Here, let me move, my bad, let me move the camera angle a little bit. Actually, my bad, let me, okay, that's better. Okay, now here, let's go to the second part. Here, step 2, we're just going to substitute what that f of x plus h, what it was. So now here we have the limit as h approaches 0. Now what was f of x plus h? It was negative 5x squared negative 5x squared minus 10xh minus 5h squared plus 2x plus 2h minus 12 minus f of x all over h. Okay, now here we know, let's go back for a quick second. If we know that f of x, what was f of x equal to? It was equal to negative 5x squared plus 2x minus 12. So if I said, hey, what is negative f of x? Basically, what do you think would happen? It changes the sign for each thing within f of x. Okay? And that's what we're going to substitute here for that negative f of x. So now we have the limit as h approaches 0 of this whole entire thing of negative 5x squared minus 10xh minus 5h squared plus 2x plus 2h minus 12 plus 5x minus 2x plus 12 all over h. Okay, good. Now, how do we continue forward? What are you thinking? What are you thinking? Here, let's combine like terms. Okay. Combine like terms. So here, what can we combine? We can combine this 2x. Notice that this 2x and negative 2x cancel. This negative 12 and positive 12 cancel. And, oh, whoops, sorry, I forgot. This should be 5x squared. My bad. There should be a 5x squared. And notice that this 5x squared and negative 5x squared cancel. So what are you left with? You're just left with the limit as h approaches 0 of negative 10xh minus 5h squared plus 2h all over h. So now it doesn't look too bad. Now once we get to this point over here, there was a little trick that we did before that maybe you remember, maybe you don't. But notice that we want to substitute 0 for h. But you can't do that because you can't have 0 in the denominator. So what's a little trick we can do to kind of get rid of this h in the denominator? Hint, there's an h that is common in all three of these terms. So what can we do to kind of get rid of this h? Notice that this is the same as h approaches 0, we can factor out an h. Factor out h. So what happens if you factor out h? Notice that this becomes negative 10, I'm sorry, h times negative 10x minus 5h plus 2 all over h. Because if I multiply h times this, I get this, h times, right? But what happens, I can cancel these two out. Now I have the limit as h approaches 0 of negative 10x minus 5h plus 2. Now we can plug in and then what happens when h is 0? Then this becomes negative 10x minus 5 times 0 plus 2, but then minus 5 times 0 is this. So now we just have f prime of x is equal to negative 10x plus 2. Oh crap, my bad. I just realized I didn't do this. Okay. So great. Now we finally have this. And let's kind of just go back a little bit for a second. What did I want to go back to? Yeah, this one. Notice, what was the nice thing we would like? Wouldn't it be nice or great if we had a process that would find the slope of the tangent line on a curve? So let's just remember, what do we want? We want to find the slope of this tangent line at x equals negative 8. What we just did right now was we found the derivative. What the derivative does is, here, if I plug in negative 8 into the original function, it gives me the y value. If I plug in negative 8 into the derivative, it tells me the slope of this tangent line at negative 8. If you need to rewind and hear that again, please do. I'll say it one more time. Here, when we plugged in negative 8 into the original function, it gives us that y value. But what we just did right now is we found the derivative of this function of f of x. Now that we know that the derivative is of f prime of x is equal to, we just did it right now, it was negative 10x plus 2. Now, if I do f of negative 8 and I put it into this function here, it tells me the slope of this line at negative 8. That takes time to fully get. Okay, so here, now if I just plug in negative 8, this is negative 10 times negative 8 plus 2. So this becomes negative 10 times negative 8 is 80 plus 2. So 82, positive 82, positive 82 is the slope of this line at this curve. Whew. Okay, sorry for the long video, but it was necessary. I hope this helped. I'll ask questions. We'll go over this in class together.